In this lesson, we're going to look at linearization.
Okay, so I'm going to draw the square root function. So I'm going to start by, here's my y-axis, here's my x-axis, and we'll label them. There's my x-axis and my y-axis. And when I want to draw the square root function, and so I happen to know that the square root of 4 is 2. So let's do that. 1, 2, 3, 4. The square root of 4 is 2, so it's going to have a height to here. As a matter of fact, I could continue. Let's continue this on, because I can. And let's take it all the way up to the square root of 9. Let's take the 4, 5, 6, 7, 8, 9, and the square root of 9 that we know is 3. And I'm going to draw that in. Let's see, that brings us to about here. So let's go ahead and draw that in blue. Here's my curve. Now, I know the square root of 4. We know that's pretty easy. It's 2. Square root of 4 is 2. Okay? So let's say that I'm going to say, well, x is going to, we're going to call this x. But I'm using this kind of as an example. But let's say this is x. X happens to equal 4, but for our, this is to explain why we would use this. But it could be anything. So x is equal to, x is this value here, which means that this is f of x. And let's imagine that I have this other value here, a, and I want to know what is the square root of a. And that's not, this happens to be the square root of 5. It's not as obvious, right? We don't, that's not one that we can do in our head, the square root of 5. So this is going to be the square root of f of a. Now I use the 4, square root of 4, and the square root of 9 to help me draw the curve that looks really like a square root curve. But for what we're doing, I would probably want a to be much closer to 4. So, so what I'm going to do is I'm going to get rid of the 4 and the 9, and I'm only changing this because I want, let's see, let me fix this. I wanted to have the curve correct. But let's imagine that this is still f of x, and this is still, let me get rid of this. This is still x, and this is a, and that's f of a, but a and x are actually very close to each other. They're not one unit apart. They're really, really close to each other. Again, I used 4 and 9 to help me draw the curve so that it looked correct, okay? Now, I may know really quickly what x, given a value of x, what f of x is, and an example would be if x is 4, the square root of 4 is 2. But if x is 4.1, finding the square root of 4.1 is not as obvious. We don't have that right away. We'd probably put it into our calculator. So this is, using linearization, we would find the square root of 4.1 fairly quickly. And this is how it works. Is that we imagine that we have a tangent line, or we want to have a, actually this is a secant really, and it's a line that's going to go through these 2 points right here, x, f of x, and a, f of a, okay? Now, as a gets very close to x, that line that I just drew, which is a secant line, joining the points x, f of x, and a, f of a, as a gets very close and approaches x, that secant line becomes a tangent line. And that's one of the sort of things that we learned early on when we were learning what a derivative is, okay? So the question is, since it's not easy to find the square root of a, okay, so imagine that this is the square root function, and I can say that, in fact, we happen to know that f of x is actually equal to the square root of x. And it's easy to find the square root of x because x happens to be 4, but not easy to find the square root of a. I do know that if I wrote the equation for that line, and we'll call this line L of x, all right? So you have f of x and L of x, where L of x is the secant line. So if I knew the equation for L of x, which is going to be a line, it's linear, right? It just has an intercept and a slope. It's it's very simple. Then we can plug our a value into that equation for that line very easily, right? And find its value because it's linear, right? So let's figure out how we would find L of x. And I'm going to see, let's see if I can move this up. Oh, I can, good. All right, so, well, let's take what we know as the equation for a line given point slope form, okay? Because, yes, point slope form. If I have a point, and I'll call that point x and y, and I have a slope, we'll call it m, then the equation for our line is y minus the y value from our point. I should call this x1 and y1, and we'll put a comma between them. So y minus the y1 from our point, that doesn't look very good. Let me see if I can fix that. Is x1 comma y1. There we go. So y minus our y1 is equal to the slope times x minus our x1. Now this is algebra, right? That's the equation for a line given the slope and a point, okay? So if we look at this, we actually have the slope and the point. Our point, well, we're not going to use f of x, because when we talk about the x and the f of x, x is representing our entire domain, our independent variable, and f of x represents our entire range, okay? So our x value that we're considering is a, and its y value is f of a, okay? So when we talk about our point, I'm going to change the color to blue. Our x1 is a, and our y1 is f of a. That's the point. And our slope, what's our slope? What would our slope be? What is the slope m of this line, L of x? What is the slope of L of x? Can anyone, what would you think it would be? Isn't it the derivative of f of x? Isn't it f prime of x at a, right? Because, of course, the slope of f of x is changing. So when we're talking about this secant line right here, its slope, it goes right through a, f of a. Its slope is the derivative of this curve, f of x, at a. So it's f prime of a, okay? So coming back down here, our slope is f prime of a. And so this is our x1, xy1, and this is our slope. So our line that we're looking for, which is L of x, this L of x line, is going to be y minus y1, which is f of a, is equal to the slope, f prime of a, times x minus a. And now we have, this is the equation for that line. Now, so if we solve for y, we have y is equal to f of a, I'm adding f of a to both sides, plus f prime of a times x minus a. Now here,
y is the equation for this secant line, which is, of course, L of x. So y is L of x is equal to f of a plus f prime of a times x minus a. So since this is a square root function, if we know that a is 4, then we also know that f of a is f of 4, which is the square root of 4. We know that, and that's 2. We can find f prime of a by finding the derivative of the function f of x. And that means we find f prime of 4. That's pretty straightforward. And that's going to give you the values we need for f of a, f prime of a, and a. And we'll end up with an equation for a line that is the secant line between a and some value of x that's very close to a. And so we could find, say, the square root of, on this side of a would be maybe 3.9 if a is 4. Or we could work on this side, to the right, and find the value of the square root of 4.1, and on this side, if x is on this side of 4, it would be, say, the square root of 3.9. So we can find it because they're going to have pretty close to the same height on this line, L of x, our secant line, as we do on our curve, which is the square root of x. Let's do an example of this.
All right, so what we want to do here is, if we know that we have this function f of x, and f of x is equal to the square root of x. And what we know, our given, is that we know what f of 4 is. F of 4 is the square root of 4. The question is, what is f of 4.1? Well, of course, actually, I got ahead of myself. Let's write down, this is the key thing, is that we know that f of 4 is 2. Very simple. So what is f of 4.1? That's what we want to find. And we're going to use linearization to solve this. We're going to use the linearization formula that says that L of x, which is our secant line through our f of x, from x equals 4 to x equals 4.1, is equal to f of a plus f prime of a times x minus a. This is our formula. Okay. So we're using this formula to find L of x, or L of 4.1. Okay? We're saying that this line is very close to the square root curve. So whatever height this line reaches, very close to x equals 4, is going to be pretty darn close to what the square root would be even at 4.1, because we're really, really close. All right? So we're looking for L of x because what we're saying, okay, and just what this means, is that this L of x is very close to f of x when x is approaching 4, okay? So as x is really, really close to 4, L of x and f of, I should call this f of x, excuse me. So L of x and f of x have the same height for values of x close to 4, all right? So we want our a to be what we know, 4, because we know the square root of 4, right? So we want a to equal 4, because we know what f of a is. Let's move that up here. And we know what f of a is, right? f of a is f of 4, which is the square root of 4, which is 2. So move that up. And then we want to know what is f prime of a, which is going to be f prime of 4, which is, that's the question. So let's move that up because we've got to go find what is f prime of x, okay? So let's work that out in black, okay? So if I know that f of x is equal to the square root of x, that means that it's equal to x to the 1/2, correct? That means that f prime of x is equal to, we bring the 1/2 down, is 1/2 times x to the 1/2 minus 1, right? So it's a negative 1/2, and that's, right? Now let's simplify this. This is 1 over 2, that's the 1/2, and x to the negative 1/2 means it belongs in the denominator, right? So x to the 1/2 goes in the denominator, and 1/2 means square root. So there we have it. That's f prime of x, 1 over 2 radical x. So I'm going to take this and let's move this bit of work down here. And what I want to do is finish off writing what is f prime of 4? It's 1 over 2 times the square root of 4, correct? That's, I'm taking f prime of x from what we have down here, and I'm plugging in a 4 to find f prime of 4. And so it's going to be equal to 1 over 2 times 2, so 1/4. Okay, so I have what I need to do this linearization, to find this linearization equation right here. I have a, I have f of a, and I have f prime of a. Okay, so I'm going to rewrite this linearization with the values for f of a, f prime of a, and a. And what do I get? I get L of x is equal to f of a, and f of a is 2, plus f prime of a, which is 1/4, times x minus a, and a is 4. So this is the linearization equation for the square root of x when a is 4, okay? So we want to find, I'll go back to it, what then is L of 4.1? Because we know that very close to 4, L of x and f of x have the same height, which means that L of 4.1 is going to be very close to f of 4.1. They're pretty close to the same height, same value. Well, it's going to be 2 plus 1/4 times 4.1 minus 4. And of course, this can be simplified to 2 plus 1/4. And of course, 4.1 minus 4 is 0.1. And 0.1 is 1 over 10, isn't it? So let's just write that as 1 over 10. That's 0.1. So that's equal to 2 plus 1/4 times 1/10 is 1 over 40, right? So it's 2 and 1/40. So what this tells us then is that the square root of 4.1 is very close to 2 and 1/40, and you can work out the decimal equivalent of that with division.